Hey guys, Fuzzy Nop here. This is part 2 of Wargames for Learning. In this tutorial, I'm going to show you a little bit about, a little more about the Smash the Stack wargame. We're going to cover how to use GDB to take apart a program. And if you have no idea what I'm talking about, I suggest going back and watching the first video. In that one, you'll see where we're at. And that's all. So let's get started. So real quick, we're connecting to smashthestack.org. We're using this address and this password to get to level 1. Okay, so let me copy that in. And the password is level 1. Okay, great. So we're here, changing the directory to levels. We can see that if we try to run level 1 with a password, it says no such directory. Oh, because I spelled it wrong, of course. We can see that we fail, right? So we need to type the correct password here. And what we can do is use GDB to take apart this program. Now, this isn't the only way to solve this this level, but it's a good opportunity to look at some of the commands in GDB. So if you've never used this before, I'll go really slow with it. I'm pretty new to it as well, but it seems to be the it's like a really powerful Linux tool to take things apart and really understand what the program is doing, even if you don't have the source code, as we do not for level 1. There's no source code, it's just a compiled program. So to take apart level 1, we'll just type GDB, and we'll type level 1 after it. Now at any time we can type run, and that's the same as typing typing run in GDB, since we specified level 1 here, is almost the same as typing this. Okay, so if we type something after run, that's going to be passed as the argument. So if we type password, it's the same thing as before. It still says fail, just like before, and then it exits, but it gives us a little more information if it exits normally or fails or whatever. So one thing we can do in GDB is disassemble and deconstruct the program to give us the assembly language output. So to do that, I'm going to type disass main, and that's disass main. And you see what it does, it dumps out a whole bunch of crap here. Okay, and personally, I don't like to look at this this assembly language style. The other you can change it. This is the AT&T style, and you can change it to the Intel style by saying set dis Intel. And if we type disass main again, you'll see there's less percent signs and dollar signs and all that, and it just kind of spells it out in words. It's a little bit easier to read. And hit enter to display more. So this is the entire program. Now it's pretty daunting at first, but if you're not familiar with assembly, I suggest going and Googling and reading some basic assembly commands. I'm not going to cover everything in depth here. So basically what we're looking for is going to be over here on the right hand side. It's going to give us not quite variable names, but it's going to give us library names, and we can guess that when we type this password in, it's probably going to use some library to compare. And you just kind of have to know this, but the library it's going to use is this string and compare here. So what we can do is we can set a breakpoint here to stop the program running when it gets to this compare. So you can just trust me on this, but this is the important part of this program. It's where it's taking what we typed and it's comparing it to the actual password that the program is expecting. So over here is the memory address. So we're going to put a breakpoint at this memory address. So I'm going to copy this, and down here you can type out the word break, or you can just abbreviate by saying B. Now if you're breaking at a memory address instead of like a function name or something, so you're going to have to type an asterisk first. That's going to let it know that you're about to type a memory address. So I hit B, asterisk, and then the memory address. I hit enter, it's going to say breakpoint 1 at that memory address. So great. So now if we type run, and we'll give it password again, it's going to say that it hit this breakpoint. So it hasn't exited yet. Now there's another command to inspect the registers, and they can be abbreviated by typing I space R. So what this does is it gives us an output of all the registers. So what you want to look at now, you may not be familiar with registers, so if you're not, what the registers are, they're basically the CPU's small memory to store things like memory addresses and temporary like constants and things. So it's very limited, and they are general purpose, but some of them have specific purposes. Like EIP is always going to point to the instruction that we're executing. So you see, here's this memory address here, and it's the one that we stopped the breakpoint at. So EIP is kind of like it's like a pointer to where the program is executing in memory. Because if you know, if you don't really have a computer science background, this may be a little overwhelming, but you know, you have stored program concepts, so you have data and instructions all together in memory and memory addresses. So we're looking at the memory addresses here, and at that memory address may be an instruction to execute, or it may be data like the password that we're looking for. But EIP is pointing to the instruction, so it's pointing to that string compare library call. Now if you look back up here, what it's doing is, where'd it go? String compare. And then it tests EAX to EAX. Okay, so string compare uses this EAX. Now, what we want to do is we want to examine the data in EAX. Now, we can examine memory all we want by using the X command. And there's different formats to examine. And so we put an X and then we put a slash. And if you can't see that, let me make that bigger. So, see there's a X and a slash. Now we can specify that we want you know, bytes at a time. So we can type a B. We can even say we want 200 bytes, and we can say we want 200 bytes at EIP. And we need to put a $sign here, I think. And what that's going to do, it's going to give us a bunch of garbage. Can't really see. What it's doing is it's giving us all the memory after the instruction pointer. Now that's hard to read, but we could say we want maybe less than 200. We could say 20I for instructions. Now this is a little bit more familiar. Here's the next 20 instructions after EIP. So that's, you know, our string compare function, and then it tests, and then it does a little bit of logic. And down here is where it's going to call the function to do what we want. And you can see that if it doesn't come back good, it's going to jump to main plus 171. So it's actually going to skip over this this one here. This is main plus 164. It's going to jump to here, so it's going to skip that. So don't worry about that for now. So what we also can do, and this is where the magic comes, is we can specify that we want to examine a string value. And we can say we want to examine a string value at EAX. And there you go. There's the password that it was looking for. Now, this isn't the only way to do it, but you've seen a few commands now, so hopefully you can go back through and take a look at that. Let me show you another way to solve this one. Sorry. And it's a lot easier. You can type strings level 1. And it's going to go through the program and list all the strings. So you see there's like a win string, fail string, bin/h. That's the command that it's executing. Oh, there's the password. And I mean, you could kind of look through and go, oh, I think that's a password, and try it. You could also say ltrace level 1. I think I need to say, yeah, so ltrace./level01. And in here, it's going to show you the, I need to type password, that's what it actually calls. It's going to show you what it's doing. So it's calling the string compare function, and it's comparing password to OMG password. Well, that's pretty obvious that OMG passwords is the thing we need to type. So just for conclusion's sake, you can see that that was it. Now, If you don't know what you're doing here once you get this, you should really read the README on the Smash the Stack website. So that's all for this tutorial. I will be making some more, a little more in depth with different things with GDB and software exploitation. If you enjoyed this tutorial, go ahead and subscribe. Thank you.